Welcome to the Melon channel on YouTube, and welcome to Handyman Mending. Today we are repairing a car radio. Let us check what the problem is. When connected to a power supply, whatever input from the front panel, the radio does not respond. There is no sign of powering on. Inspecting the circuit board did not give any clue since there is no visual indication such as burnt copper track or damaged component. In order that access to nodal joints by, for example, multimeter probes to be easier, the circuit board is to be separated from the body. Here we are disconnecting the wiring connections. In the next step, we will need a soldering iron. Due to relatively large copper area, a wide soldering iron tip is used to desolder this joint. The tip size ensures heat transfer more than compensating for heat conducted away from the joint. The tin solder is removed by a gentle but firm vertical knock when it is put in a molten state. Later in this video we will use the suction method to remove tin solder on this circuit board. On the green silkscreen surface there is some white chalk. It will be cleaned after repair and before reassembly should it be successful. We take our time to pace our steps moderately. The far right is catching, we pull it open up slightly. Here we go, the circuit board is separated from the body. A multimeter is used to trace from the connector at the back of the radio to the circuit board. We are supposed to have circuit continuity from this pin to the ground on the circuit board, which is also the chassis ground. The first probing action joins the positive and the negative clamp to obtain a continuity beep sound from the multimeter. The second probing action confirmed like the ground pin has lost circuit continuity, but this time there is no beep sound. This is indicative of an open circuit fault that would also agree with the observed behavior very well. We do not know at this stage that if this is the only fault, yet rectifying it would allow us to diagnose further. We will detach the toroidal inductor to assess further how to rectify this circuit continuity problem. Put the soldering iron tip to the solder side of the circuit board, while a sideway pressure is put on the component from the other side. This component has two leads and we are displacing outward a little bit on each side at a time. These two through holes should be cleared of tin solder since the inductor will need to be inserted back into its position during reassembly. A suction pump is used. This device is often referred to, quite aptly, as the solder sucker. And this is the suction tin removal method that was mentioned earlier in this video. Another method using solder wig I call the wetting method, which is not needed in this repair. With the inductor out of the way, we can get closer to the problem location. Arrow shows the base of the ground pin. Circle highlights the nearest point the discontinuity is detected. Looks the open circuit is buried. Our decision is to make a bypass ground path. Since this ground is not only signal ground, but it is also power ground that carries higher current, the bypass must be sufficiently current capable and also as short as possible. Our bypass link is close to the metal body of the switch. At first glance we might be concerned of possible short circuit, but this is not a problem since both of them are equal potential at ground voltage. When soldering the inductor back onto the circuit board, notice that the tin solder wire is fed off to the tip of the soldering iron has been in contact for preheating. After feeding tin wire to the new joint, the soldering iron stay a little longer at the joint to allow temperature get through the hole all the way to the other side. It is highly desirable that tin solder is not just surface deep, but it fills up spaces completely. The new bypass link bridges the base of the ground pin directly to the anode of a nearest diode. When the radio is in operation, this link needs to pass a few amperes of current and occasional peaks at higher values depending on the output sound level at that instance. Let us check if the solution works for us. Connect to power supply. Push in the right-hand side rotary dial, and unlike the test in the beginning of this video, a clear difference is obtained. The display backlight turns on, and the LCD is showing information. Push in the left-hand side rotary dial turns the radio off. Since other functions such as tune-up and volume change are normal, we gain confidence to start reassembling. The microcontroller has narrowest pin pitch amongst all the components on board, so we introduce a conformal coating sealant to give better protection against dirt, moisture and corrosion. Apply the compound to all four sides of the integrated circuit and wait for it to set. In the previous video clip the viewer may notice the power on dial on the front panel has a slight wobble. This has been dealt with by reassembling the affected parts of the front panel. The board has now been cleaned, there are no more chalky marks on the green surface. Squeeze a small amount of silicon sealant between the adjacent capacitor and inductor since these are the tallest and heaviest component on our printed circuit board respectively. This will give that little extra mechanical strength for our peace of mind. Off the screen we performed a few tests to ensure that there is no other issue that we have missed out. This is a slide of the result. There is a 12-hour continuous operation on our workbench to help settle our doubt. Next we show a final clip. Thanks for watching. Please give us a like, vote and subscribe to the Melon channel on YouTube. See you in our next video. Bye.